everyone. In the last video, we discussed about the atmospheric some natural applications of atmospheric refraction. And last topic was there is scattering of light. Now in this, we are going to discuss some applications based on the phenomena scattering of light. You know that when light passes through matter, that is transparent, solid, liquid or gas, a fraction of it is thrown randomly in various directions. This phenomena is called scattering of light. It is responsible for many natural phenomena. So first of all is there explain Tyndall effect with examples. So Tyndall, actually the the name was the scientist Tyndall. The phenomena of scattering of light was first studied by Tyndall. So after his name, this phenomena is known as Tyndall effect. There are many atmospheric example when a beam of light enters a dusty room through a small hole. The tiny dust particles present in the air of room scattered light and make the path of light visible like this is, so you can see in that many particles, you can see them, they are swim. Okay, so when sunlight passes through a canopy of dense forest, the tiny water droplets present in the mist scatter the light rays of sun. Okay, so this is when the light coming from a small hole, and this is when the light coming from the canopy of a dense forest. So here is what in this, the air particles, the tiny dust particle present in the air of the room scatter the light and make the path of light visible. But when sunlight passes through a canopy of dense forest, the tiny water droplets present in the mist scatter the light rays of sun. So in 1859, Tyndall found that when sunlight, which is a mixture of 7 colored lights, passes through a liquid containing fine suspended particles. So what he just observed that the blue colored light having shorter wavelength is scattered much more than the red light having longer wavelength. Okay, so he just observed the blue colored light having shorter wavelength is scattered much more than the red light having longer wavelength. He further found that the color of scattered light depends on the size of scattering particles. Okay, so he further found here he scattered the blue colored light having shorter wavelength is scattered much more. Those who are having the colored light having shorter wavelength scattered much more than the red light having longer wavelength. So one is the wavelength. He further found that the color of a scattered light depends on the size of the particle. Here is a wavelength. One factor is the wavelength of the colored light. Second is the particle, the size of the particle to which they will collide. So if the size of the scattering particle is larger than the wavelength of visible light, means when white light coming from the sun hits the larger particles, it gets reflected or scattered in different direction. So what we are doing here, coming from the sun hits these larger particles. What type of particles we are having? Larger particles. So it gets reflected or scattered in different directions. Okay. So the different colors of light, white light, are reflected by the dust and water particles in the same way. Different colors of white light are reflected by the dust and water particles in the same way. So the different colors of white light are reflected by the dust and water particles in the same way. Due to this, the scattered light appears white. Okay, the second thing is that the air molecules, that the nitrogen and oxygen gas present in the atmosphere, are smaller than the wavelength range of visible light. These are smaller. And the back one, the first point we just read that they are larger than the wavelength range of visible light. So these are the smaller. Nitrogen and oxygen gas present in the atmosphere are smaller than the wavelength range of the visible light. So when light coming from the sun hits these particles, the lower wavelengths lights, that is blue, scattered much more than the higher wavelengths light, that is red. Okay, so this is what the air molecules, that is nitrogen and oxygen gas present in the atmosphere, are smaller than the wavelength range of visible light. In the first point we have taken the larger than the wavelength of the visible light. So this, when light coming from the sun hits these particles, the lower wavelength like blue scattered much more than the higher wavelengths lights, that is red. So blue सबसे ज़्यादा scattered होता है, और जब larger होती है तो the different colors of white light are reflected by the dust and water particles in the same way. Due to this the scattered light appears white. वो white ही दिखाई देती है जब बड़े पार्टिकल से कोलाइड करता है, और जब स्मॉलर पार्टिकल से कोलाइड करता है तो उस टाइम पर सिर्फ ब्लू लाइट, मतलब लाइट जो शॉर्टर वेवलेंथ है, ब्लूज की शेड जो होती हैं वो स्कैटर्ड होती हैं देन द हायर वेवलेंथ लाइट्स लाइक द रेड. सो ऑन द बिहाफ ऑफ दिस वन क्वेश्चन अराइजेस हियर, व्हाई द स्काई अपीयर्स ब्लू? The sky appears blue because the molecules in the air, that is nitrogen and oxygen molecules, scatter blue part of the sunlight than the other shades. अभी हमने ऊपर पढ़ा है कि जो shorter wavelength होती हैं, lower wavelength lights blues scattered much more than the higher wavelength. तो यहाँ पर nitrogen, the sky appears blue because the molecules in the air, nitrogen and oxygen molecules, scattered blue part of the sunlight than the other shades. So according to Lord Rayleigh, amount of scattering is directly proportional to 1 upon lambda to the power 4. Lambda, you know that, wavelength of light. Wavelength of light. So this is, so formula is amount of scattering is directly proportional to 1 upon lambda to the power 4. Scattering जितना wavelength कम होगा, so that the amount of scattering that will be much more, because these are inversely proportional to each other. Wavelength of light, wavelength जितना कम रहेगा, scattering of amount उतना ही ज़्यादा होगा according to this formula. So the wavelength of violet, blue, green and red lights present in sunlight are respectively 4000 angstrom, this is the unit here, angstrom, 4400 angstrom, 5000, 7000 angstrom. So the value of 1 upon lambda to the power 4 will be maximum for the violet color. But sunlight has very little violet color. Okay, sunlight has very little violet color. So now blue color is the next which is scattered the most. Violet बहुत कम होता है, that's why next color जो सबसे ज़्यादा scattered होता है, that is the blue light. So the most scattered blue light enters our eye and the sky appears blue. So this is like, this is the scattering here. So blue color जो होता है वो सबसे ज़्यादा scattered होता है, यहाँ आकर फिर हमें ये blue color दिखना शुरू हो जाता है. So that is, so the formula is important. Amount of scattering is directly proportional to 1 upon lambda to the power 4. Lambda means wavelength of light. Wavelength जितना कम होगा, scattering of amount उतना ज़्यादा होगा, because both are inversely proportional to each other. Okay, now the next question, why the sun appears red at the time of sunrise and sunset? Why the sun appears red at the time of sunrise and sunset? So at the time of sunrise and sunset, when the sun is near the horizon, okay, the sunlight has to travel the greatest distance, through the atmosphere to reach the observer. Okay, so most of the blue color, like this, most of the blue color and other shorter wavelengths are removed by scattering. वो इतने scattered हो जाते हैं कि वो दिखाई नहीं देते. So most of the blue color and the other shorter wavelengths are removed by scattering. The red color, only the red color, the shade of red, like the orange and red color, scattered having the largest wavelength is scattered least and reaches to the observer's eye. Therefore, the sun looks reddish at the time of sunrise and sunset. So this is the reason. So most of the blue color and other shorter wavelengths are removed by scattering. The red color having the largest wavelength is scattered least and reaches to the observer's eye on the earth. So it reaches. So therefore the sun looks reddish at the time of sunrise and sunset. But what happened at the noon? The noon, the sun is overhead. Okay, because at noon time the sky appears white. So at noon the sun is overhead. Okay, it would travel relatively shorter distance. Hence, there is much less scattering of blue color and violet color and the sun appears white. So here is a question can be taken as why the sky appears white at the time of noon. So at noon the sun is overhead, would travel relatively shorter distance, hence there is much less scattering of blue color and violet color of the sun appears white. So these are some reasons. Now there is some homework for you, that is why clouds appear white. This is the first question, why clouds appear white. Next, why infrared photograph is possible in fog and mist, and why red light is used in danger signals. So these three questions for you on the behalf of the topic that we had discussed right now. You can give the answers because same reasons are there. So this is now one activity is left. That activity was based on the Tyndall effect to perform an activity which shows scatting of light through colloidal solution. For this I will send you a video for the reference so you can see in that. So I hope the chapter is over now. So just try to complete your work by the next turn. Thank you so much.